How do you solve this equation? I don't know about you, but I have this undeniable, irresistible urge to subtract 1 from both sides of this equation. I have absolutely no self-control, so I'm gonna do it. Oh yeah. Okay, now what? Well, I'll tell you what. I want to divide by 2 so goddamn bad. I'm gonna do that. Oh yeah. There we go. So we solved this equation by subtracting the 1 and then dividing by the 2. But why do we do the things we do? Well, in short, we look at what's happening to x. It's being multiplied by 2, and then 1's being added to that. We look at the last thing that happens to it, adding the 1, and then we do the opposite thing. The inverse, or the opposite thing of adding 1 is subtracting 1. Addition and subtraction are opposites. Why do we divide by 2? Because division by 2 and multiplication by 2 are opposites. They undo one another. Now look at this equation. We have x as our exponent on 2. We want to do the opposite thing. The opposite thing of exponentiating with a base of 2 is taking the logarithm of base 2. So, just like if the equation said x plus 2 equals 12, we would subtract 2. Since this equation reads 2 to the x equals 12, we're going to take the logarithm of base 2 of both sides. Now, just like if you add 2 and subtract 2, nothing happens. If you take the log base 2 and then exponentiate with a base of 2 to the x, you just have x. At this point, the equation has been solved. X is equal to the logarithm of base 2 of 12. And you can get approximations for that with your calculator. Oh well, look what we have here. 27 equals 2 to the power of 3x minus 1. Okay, we want to reach x, so we need to start undoing things to x. The last thing that happens is exponentiation with a base of 2, so take the log base 2 of both sides, like before. From now on, we're just going to skip this step. We know that this is going to cancel, so we can just write that the log base 2 of 27 equals 3x minus 1. Now what's happening to x? Well, 3 times x minus 1. Last thing is that minus 1, so do the opposite, add 1 to both sides. And finally, divide by 3. And again, if you want an approximation of this, just use your calculator. Ooh, look how fancy this one is. All right, we got 3 times 2 to the x plus 8. Last thing that happens is that plus 8, so subtract 8 from both sides. Now divide by 3. And finally, since we're doing 2 to the x, take the log base 2 of both sides and we'll get that x equals the log base 2 of 9. Oh my goodness, look at this equation. Okay, so we have x, then we square it, then we exponentiate with a base of e. So the opposite of that is a logarithm with a base of e, which is the natural log. So we'll take the natural log of both sides. Okay, and to undo x squared, we take the plus or minus square root. And so that gives us that x equals the plus or minus square root of the natural log of 73. Now you do want to be careful when you get something like this because we're taking the square root of an expression. So you do want to verify that the natural log of 73 is a positive number. And it is simply because 73 is larger than 1. So this is our solution. Look at this monster. 10 to the power of x squared plus 2x plus 1 times 5 equals 13. So we have a quadratic as an exponent. Well, I'll be damned. How on earth are we going to handle that? Okay, so we have multiplication by 5 at the end, so let's divide by 5. All right, now we're exponentiating by 10, so let's go ahead and take the log base 10 of both sides. Okay, well, luckily this little guy factors into a perfect square, right? This is x plus 1 squared. All right, so take the plus or minus square root. And again, you can verify that the log base 10 of 13 over 5 is positive. And finally, let's subtract that 1. And there's our solution. All right, we got 6 minus 5x, and that's being exponentiated with a base of 1/4. So we take the log base 1/4 of both sides. It sounds stupid, but it's perfectly legit. So we're gonna get that 6 minus 5x equals the log base 1/4. I can't believe I'm saying this out loud. Log base 1/4 of 3. All right, and let's subtract 6 from both sides. And then we'll divide both sides by -5. Okay, there we go. That's a number. All right, this thing's gonna be a little different. So there's no real way to combine this e to the 2x and this -4 e to the x in any way that's gonna really help us. So instead, what we can realize is that this sort of looks like a quadratic, okay? So I'm gonna write it slightly differently. Now, we have e to the x squared minus 4 e to the x minus 5 equals 0. So we're going to make a substitution so that this looks like a quadratic. So let's let u, not u, the letter u, is going to be e to the x. So that this equation becomes u squared, right? E to the x is u squared minus 4u minus 5 equals 0. So we get that u is either 5 or -1. Alright, so we know what u is, but remember, we don't want u. No one cares about u.
Nobody likes you.
You can just get out of here. Okay, we want x. And u is e to the x. So we know that e to the x is 5, or e to the x is -1. And how do we solve these? Well, we take the natural log of both sides. So we get that x is the natural log of 5, or x is the natural log of -1. But the domain of the natural log is positive numbers. So this is actually not a solution because it's undefined. So our only solution is x equals the natural log of 5. Alright friends, that's gonna have to do it for this one. If you enjoyed the video, be sure to subscribe, and I'll see you next time.
Breaking barriers to entry, making complex seem elementary. Turn the century with the power of the sun. I integrate differentiated pieces into one thing, and you don't stop the rhythm and ning as I start to swing and bring rhymes to the ring. Some didn't know the kingdom lies in front of us while I summon us up scenes from a dream.